Hey everyone, welcome back to my channel. I am Mihir Pawar, a fellow student here at SIDAC Mumbai. And today, as a part of our communication activity, I am going to explain the topic of object-oriented programming in Java. Understanding the principle of OOPS is very crucial for any aspiring software developer, and Java provides an excellent platform to explore these concepts. So without any further delay, let's dive right in and explore the fundamentals of object-oriented programming. So in this session, we are going to cover all the topics related to object-oriented programming. So these are the topics covered from classes and objects to all the major pillars of the OOPS. We are going to cover everything in this short video. So what is object-oriented programming? So it is not any algorithm or any method function, nothing. It's just a style of writing code where concepts are modelized as object and these objects have some properties and behavior. Now imagine you are creating a program for managing your library. So in this library program, we have books, and with each book, we have every book has their book title and book author as a attribute. So in our traditional or procedural way of programming, we might create variables like book title and book author for each book, and this will create a huge mess, a big code, big chunk of code. But in object-oriented programming, we encapsulate all these attributes in a single entity called object. So instead of writing a big code, we are breaking code in different parts so we can manage this very efficiently. This is object-oriented programming, just a style of writing code. So let's dive into classes and objects. What are objects? Objects are entities in the real world. So any object in the real world like car, a mobile phone, a pen, etc. All these are objects in our programming language. And classes are group of these entities. So classes are nothing but blueprint of our objects. So for this, let's take an example. Let's say I have a pen in my hand. This pen has color black and it also has a tip, let's say 5 mm. So we'll write here. So color is black and tip size is 5. Now we have set properties of this pen, that it has a color, it has a tip. Color is black, tip is 5. And we can also change this color, set this color by our methods. We can change our color by set color and change our tip by set tip. So for this, let's say a code. So to save time, I have already written all this code. So to create a class, we have to write a class keyword, then name of our class. And in this block, we have to write all the properties of our class, of our object. So what were the properties? It was color, tip. So I made two variables like color and tip. And these are methods to set color and tip for our pen. So this is class. Now you will say that how to access this, how to create an object and access all these properties. So for that, we have to write a single line this. So we have to create we have to write our name of the class. So it will give reference for our object, and our object name P1 equals to new pen. So your new keyword will allocate memory for our object in heap. And this pen is nothing but a constructor. We'll see it later. So now what we have done here, we have created a pen object called P1. So now we will set color for our pen. So how to set it? Simple. We have to write P1 object name dot. By writing this dot, we are accessing all our, we can see all our attributes from all our properties from our class pen. So when I write here like this, dot set color, I can set color for our object. So this is how we access properties from our object, from our class. So p1 dot set color is written here black, and we can print it. And c1 p1 dot set tip, that is 5, and we can print it here. So I will run this. So by running this, we can see we have called our objects from this. So now let's talk about access modifier. What are access modifiers? Access modifiers are the keywords in our programming language. So these keywords can control the visibility of our properties and methods in our class. So they determine that which part of our code can be accessed from other parts of our other parts of our program. So there are basically 4 types of access modifier: public, protected, default, and private. So public is accessible everywhere in the program. It is accessible in class, package, subclass, and in another package. So if we declare our variable public, you can access it anywhere. But if you declare your variable like protected, it can be accessible in class, in its own package, in subclass. Subclass meaning it is accessible in subclasses are actually child class, which inherit properties from their parent class. So they have inheritance relationship. So that's why they are accessible, but they are not accessible globally in another package. So this is our protected. Default is our implicit access modifier. So we don't need to write default. If we declare our variable directly, it is default. So default is accessible in class and package only. So if we don't declare any access modifier, they are accessible in class and package. So about private is only accessible in its class. So we have seen our last program that if I declared private in our program, they were not accessible in main method in another class. They are accessible only in their own class. So this is about access modifier. So now let's see our access modifier in our pane class. So by default, it is default. So it is our implicit access modifier. So by default, it is accessible in this package and also in this class. But if I write here public, now this is accessible everywhere in every other packages. It is public. But if I write here protected, now this is accessible only in this package and also in sub package, sorry, in subclass of another package. It's not accessible globally. Now if I write here private, now this is only accessible in this class. Now you will say, in our main method, how is this accessible? See, it is not accessible. It is saying the field pane.color is not visible. Why not visible? Because we have written here private. So this is beauty of our private access modifier. But still, if you want to set color, what you will do? For that, we have to learn getters and setters. So let's see what is getters and setters. So now let's see what are getters and setters. So earlier when we saw that when we declare our variable as private in our class, in our pane class, at that time it was not directly accessible outside the class in our main method. So I declared private in front of our color variable. So our color variable was not accessible in our main method. So this is where getters and setters comes into play. So getters and setters are methods that allow us to retrieve by get and to modify by set the values of private variables respectively. So now we can access all our attributes by getters and setters even if they are private. So now let's see our code. So I have written getters and setters here. So actually we have written setters previously in our code. Already we were writing setters here. These functions are setters. So for getters, we can see that I have written get color function, and in this, what this function do? It returns the color, and setters also do the same. Now you might wonder how these methods differentiate between class color and class color variable and parameters to this setter method. So this is where our this keyword comes into play. So actually now I have written here different variable, that is new color, different name. Let's say I set this parameter to color. So when we set different name, we don't need to write this keyword, but we have same name to, when we have same name, to differentiate this, we have to write this. So if I write here this dot color and this dot tip, now the compiler will know that this dot color means this is this. So this dot color means we can by this keyword we can differentiate between our variables and parameters with the same name. Now we have learned about classes, objects, getter methods, setter methods, and access modifiers. Now let's see our first pillar on our object-oriented programming, that is encapsulation. So encapsulation, forget this definition. What we see in our encapsulation? What you can see? We can see capsule. So let's create a capsule. So if I created this capsule, now you know that in capsule there are small granules, and all this medicine is encapsulated in this capsule. So similarly in programming also we have data and methods. That is, data means all the properties, and methods means function. All these are encapsulated in one single class. So this is encapsulation. We are all, what is this encapsulation? Encapsulation is defined as wrapping up data and methods under a single name. And it also implements data heading. So how data heading? Let's say I write here private. Now this data is being hidden. That's it. That is encapsulation. So now let's talk about constructors. So when I told you about when we were creating object like a pen p1 equals to new pen. So at that time that new pen, that pen was not a normal method. That was a special method. So constructors are those special methods. So what are constructors? Constructors are special type of method in a class that are invoked automatically at the time of object creation. So constructor play a very crucial role when we are initializing our newly created object. So these are some key points of our constructors. So constructor have same name as class or structure. So structure is in C++, but what the name of class we are given, like pen. So constructors will also have same name. Why? Because this helps compiler to identify which method to invoke. Constructor don't have return type, not even void. Yes. Why? Because we are using them to initialize the object. So why will give return value for that? So their purpose is only for initializing the objects. They are special methods. So constructors are called only once at the object creation. So yes, their purpose is to initialize. So that's why they are called only once. And memory allocation happens when constructor is called. Yes. So this ensures that object has sufficient memory to store all our properties. So that was about constructor. Let's see code. So now let's create our constructor. Before that, I want to tell you that when we don't create our constructor explicitly, our Java makes its own constructor, implicit constructor by default. So it has no parameters. So in any way, constructor is always called. So if we want to pass our parameters to our constructor, we should create our own constructor. And remember to follow naming convention. Student here. I will pass here. We will initialize our name here. Okay. And we know that this dot name equals to name variable parameter. Now we will give argument here, me here, and print this as so. Now s1 dot name. Now let's see what will happen. Yes, me here. Now we have initialized our property called string name, our name property. Now if you don't want to write our don't want to initialize name, you can also create constructor, like you can also say that constructor is called. Okay, I'll remove this. Now let's see what happens. Constructor is called. So this is how we create our constructor in our Java. So now let's talk about inheritance, the major pillar of our object-oriented programming. So what is inheritance? Inheritance is when properties and methods of base class are passed on to derived class. So properties and methods of base class, meaning parent class, are passed to their child class. So it's just like how we inherit traits from our parents and grandparents. So similarly, classes can also inherit attributes and methods from their parent classes. So child class inherit properties from parent classes. This is inheritance. Now let's see the code for our inheritance. So there is a base class known as animal class. So animal has property that it has color, it can eat, and it can breathe. So these are two behaviors of animals. And we also created a fish class. So fish is an animal, you know that. And fish has fins and fish can swim. But as we know that fish is an animal and we want to take all the properties from our animal class to fish class, from parent class to child class. And what to do for it? Just one word, that is extends. If we write extends our animal class, so we can now access all the properties from our parent class. So this fish get extended to animal class. Now let's see the code for it. Let's create an object. Let's create shark object equals to new fish shark dot. Now we know that shark has fins and shark has swim. Obviously, it will give it can return all this property. But can it take this property? Let's see. We have written shark dot eat. Now we will run. Yes, it works. It has inherited all the properties and behavior from parent class to base class. This is the proof. So this is inheritance. So now let's quickly see the types of inheritance. So single level inheritance. So single level inheritance is just like our previous example that base class transfer all its properties to derived class. Like animal class has transferred its properties to fish class. So that was about single level inheritance. Multi-level inheritance. So there is basically level in this inheritance. So if we created example shark class, our shark was object, but now we'll create a shark class. Now shark class inherit properties from fish class, and fish class and also shark class can inherit properties from animal class, as shark is a fish and also an animal. So this is level of inheritance. Shark can access both these classes, properties of this both classes. Now we'll see hierarchical inheritance. So it's like one father has two children. By our example, our animal class our fish class has extended animal class. Similarly, our mammal class can also extend animal class because mammal is also an animal. So this is hierarchical inheritance. And about hybrid inheritance is actually combination of all these inheritances. So there is also multi-level inheritance and also hierarchical inheritance. So also there is another type of inheritance, that is multiple inheritance. We'll see that in our interface chapter. So that's it. So now let's move to our next major pillar of object-oriented programming, that is polymorphism. So what is polymorphism? Polymorphism is derived from the Greek word that is poly. Poly means many and morph. Morph means form. So it refers that our object has ability to take different forms, many forms. It says that our object has ability to take different forms. So what we are doing here, we are trying to do similar things, but in multiple forms. So this is polymorphism. And there are actually two main types of polymorphism, that is compile time polymorphism and runtime polymorphism. So what is compile time polymorphism? It occurs, compile time polymorphism occurs when multiple methods in the same class have same name, but the parameters are different. So it have same name, same methods in a class, but the parameters must be different. So at that time, compiler determines that which method to invoke based on the number of arguments and also the types of arguments we pass. So we'll see this in code. But before that, I want to give you example that we have created our constructor in our student class previously. So there we created a student class constructor, and at that time I have passed arguments of student name and another constructor student roll number. So what we did here, we have same name of the constructor, but the parameter passed were different. So this is example of method overloading. So this part of constructor is called constructor overloading. So that was about compile time polymorphism because it happens all in at the time of compilation. Now we'll see runtime polymorphism. So runtime polymorphism occurs when the method in the child class has same name and also the parameters. So our child class has same name and also parameters as the methods in its superclass, that is parent class. So we have same name in parent class also, same method in parent class also, and in our child class also. So here the method of the child class overrides the method of the parent class, that is superclass. So we have different implementation in both of them. We have different. So we'll see this in code. So this is, and the decision to which method to invoke is made on the runtime. So that's why it is called runtime polymorphism. So before moving to code, I have this next slide, which has definition of both method overloading and method overriding. So method overloading says multiple functions. It is multiple function with same name but different parameters. And method overriding, here parent and child class both contain same function but with different definition. So this is definition of method overloading and method overriding. So now we'll see the code implementation of function overloading, that is method overloading. So I have created a class called calculator and I have implemented 3 sum methods here. So we can see it has same name sum, but the parameters are different. Here it is 2 integers. Here parameters are different, that is float, and here number of parameters are increased. So there is extra int c here, and we are calculating sum of this. So now I have created a calculator object, and we are printing sum of it by this object. So here is a problem. It says that it is double, so we have to typecast it. So we'll typecast it. Float, float. So now we can see that our first sum method we are calling sum function with two integers, here two floats, here three integers, but the name is same. So our compile know this at the time of compiler, that at when we are calling this function, it will go here. When we are calling this function, it will go here. And when we are calling this function, it will go here. Let's print it. So the values are, what happened? 3, 1 plus 2, 3, 1.5 plus 2.5, 4, and 3 plus 2 plus 1, 6. So this is where we can achieve. This is called function overloading. So this is the code implementation of function overloading. So now we'll take an example of code implementation of function overriding. So we have animal class, and here we have cow class. So this is parent class, and this is child class. So now we have defined our eat property here, eat function, where it animal eats everything. And 1 minute, and in cow section also, in cow class, we have eat function. So they have same name. And what does this do? The definition is it eats grass. So if I created a object of child class, at the time of compilation, the compiler, at runtime, Java will know that which function to call. So when I create c.it, when I create object of cow and add eat function and run that, you'll see here that it eats grass. So at runtime, it knows that which function to call. So that's why it is called runtime polymorphism. So what are packages in Java? So package is a group of similar type of classes, interfaces, and sub packages. So generally packages are like folders, and we know that in our computer, folders help us to organize our videos, images, all the stuff very easily. So similarly, packages are also folders that help us to organize our code. So what they do, they group related types of related classes, interfaces, and sub packages together. So this makes it easier to manage and find our code. So that was about package. So we'll take an example for this. We have Amazon shopping system. So in our Amazon shopping system, we have cart. We have rating system, and also we have a search system for in there. So in cart, we can add and delete items, and in search bar, we can type what we want, and we can delete also what we have searched. And in also ratings, we can give ratings and delete ratings. So we have to biologically, if we think, we have to separate all these sections. If you mix all these sections, there will be a lot of mess. So we can see every part has different type of purpose. So that's why we separate them in different folders, and those folders are called as packages. So in Java, there are actually there are two types of packages, that are inbuilt packages and user defined. So this was about user defined, that we can define our own packages and write our code in that. But in Java, there is also inbuilt packages. So let's see what are those inbuilt packages. So we know that we can take input from user by this scanner object. Scanner sc is equal to new scanner system.in. But before that, we have to know that this scanner object, this scanner class, comes from utility package, and which is a inbuilt package in Java. So for that, we have to import that package. Import java.util. We can use star to take all the classes, or we can write scanner if you want only scanner class. So this is how we import classes from packages from Java. So now we will go to our last major pillar of OOPS, that is abstraction. So abstraction is what? It is hiding all the unnecessary details and showing only the important parts to the user. So now you will say that in encapsulation also I have said that encapsulation was used for hiding, and here also I'm saying that it is used for abstraction is used for hiding. But there is difference. This is common confusion between students. So let me tell the difference between encapsulation and our abstraction. So in encapsulation, we bundle our data and methods together into a capsule. So that capsule was our class. And by using access modifier, we hide the internal state of the object from the outside world. So that was about encapsulation. We hide the internal state of object from the outside world. So we can hide there our internal state. But on the other hand, what is abstraction? Abstraction involves hiding all the unnecessary implementation, unnecessary details, and showing only the essential parts to the user. So what it emphasizes? It emphasizes providing a cleaner and simplified interface to the user. So it allows user to focus on the object rather than how it does. So that was about our abstraction. Now, for example, you have a TV room. So you don't need to know that what is the internal circuit in that remote, what software algorithms are there in TV remote. You only need to know what are the essential buttons like power on, volume up, volume down, channel change. So this is abstraction in action. But hiding all the complexity of how the remote control works, but and only providing hiding all the complexities that how internal circuitry works, but only providing a simple interface for users like on off, volume up, volume down. So that is abstraction. So we can implement our abstract class using our abstract keyword that are by abstract classes and also by interfaces. So now we will see our abstract class in detail. We will see the properties of our abstract class. But to make an abstract class, we just have to create a class and add a keyword abstract in front of it. So by adding a keyword abstract in front of our class, we can make our abstract class. So the first property is that we cannot create an instance of an abstract class. So we cannot create a object of our abstract class because they are just an idea. They are not any implementation. So secondly, we cannot have we can have abstract and non-abstract methods in our abstract class. So this is how we create our abstract methods. We just have to write abstract keyword in front of our methods, and we can also write our normal methods in our abstract class. And the third thing is we can have constructors in our abstract classes. So these are the properties of our abstract class. So now we'll see the code implementation of our abstract class. So for that, I have created an abstract class animal, and in that our abstract class, I have defined one concrete method that is non-abstract method, and it says animal eats. So in our abstract class, we know that we can create abstract and non-abstract methods both. So we have created an abstract method, and we just declared our abstract method. We have not implemented our abstract method. So this is how abstract classes or abstract function work. So we just have to declare, and all the implementation part is in the hands of its child class. So for that, I have created a child class that is horse class, which extends animal class. And here I have now implemented the abstract method walk. So now I have implemented, I have written here walks on four legs. So this is how abstract function works. We just have to declare in our abstract class, and we have to implement all this in our child class. So similarly with chicken. So now if I created a horse object from it, and we call eat and walk methods of our horse. So if I run this, you can see that horse eats and walks on four legs, and chicken also eats and walks on two legs. So this is how we implement our abstract class and abstract functions. So now what are interfaces in Java? So we know that classes are blueprint of objects. So classes serve as blueprint for creating objects. So similarly, interface also serves as a blueprint for defining classes. So interface is a blueprint of a class. For this, see the hierarchy of inheritance. I have created a, we will take an example of car. So there is an interface called car, and it has some basic properties like wheels, engine, speed. Now we know that every car has some basic properties like these basic properties like wheel, speed, and engine. Now we'll create a class named Wagner. Now, Wagner will have some its own properties in its class, but it will implement all the properties from wheel, engine, and speed from our car interface, that is wheel, engine, and speed. So this is hierarchy. There is interface, then there is a Wagner, then there is a class, and then there are objects. Then we'll make objects from car 1, car 2, car 3 from our class Wagner and interface car. So this is the hierarchy of interface. So from interface we can achieve two things, that is multiple inheritance and total abstraction. So by multiple inheritance I mean that now we discuss this multiple inheritance in our inheritance chapter. That I said there that I will discuss this in interface. So this is the time. So there is a class A and class B, parent class. Both are parent class. And there is a child class C. Now this child class C can inherit properties from both parent class A and parent class B. So this is normally achieved in C++. But if you have to achieve multiple inheritance in Java, we have to use interface. So we can achieve multiple inheritance through interface. And to achieve total abstraction, also we have to use interface. Because when we created our animal class, at that time I have written that animal can eat. So there was a concrete class that animal can eat. But I have created an abstract class which was animal can walk. But I have not defined it, only declared it. So that was not a total abstraction. That was like a 50% abstraction. But in interface, if you are creating an interface, we are achieving total abstraction. There are all abstract class. There are no any concrete class. So now let's quickly see how to use our interface. So to create an interface, we have to write a keyword interface. And now I have created here an interface called chess player. And we know that chess player can only move the pieces. So he just moves the pieces. But it is in the hand of the pieces that how they move. So queen can move in all directions. Rook can move in single direction. And king can move in all direction, but in one step. So it is in the hands of our pieces. Similarly, here chess player only in a chess player interface, we just only declared moves. So now it is in the hands of our subclasses to how to implement that. So implement word is very important. Now see, I have created class queen and use the word implement. So we know that in our inheritance there was extend keyword. So similarly to extend our interface, we use implement keyword. So I have implemented here class interface chess player. Now we are defining our function. So here also I am defining our function, and I also created king class and defining the function. So this is how we implement interface. So I have created a object queen and calling moves function. So let's run it. We can see that queen can move up, down, right, left in all direction, and rook can move up, down, left, right. So this is how we implement interface. So now we'll see what is static keyword. So we'll just see the theory part of this. Due to time constraint, I cannot explain the code part. So what is static keyword? So static keyword in Java is used to declare elements, means variables and methods that belong to class itself rather than instances. So they belong to class, not to objects. So when a variable or method is declared static, it means that only one instances or only one instance of that variable or method is declared. And that one instance or method is shared among all the instances of a class. This means that you can access static variable and methods directly using class name, not by the object name. So remember that if something is static, so it is shared by all, not just by one. So what is super keyword? Super keyword is used to refer immediate parent class object. Yes. So in Java, super keyword is used to refer the parent class or a subclass of a subclass. So it's like asking help for someone older ones. Like we ask help from our parents. A subclass is asking help for its parent. So when we use super keyword, you are telling Java to look parent class for something. So you might use super to call method or access variables that a subclass inherits from its parent class. So it is used to access parents properties, it is used to access parents functions, and also it is used to access parent constructs. So that was about super keyword. So if you are still watching this video, I'm truly grateful for your dedication and support. Creating this video took a lot of effort, burning the midnight oil till 5 a.m. in the morning. So make sure you hit that like button and share this with your friends. So till that time, happy coding.